In this video today we are going to go over points of inflection. So the concavity of a graph of a function changes at its point of inflection. So here it was concave up and there it's concave down, and so where those switch, that's where our point of inflection is. Again, concave down, concave up, point of inflection. So point of inflection is when so it says if C and f of C, this would be our value of x and our value of y is a point of inflection of the graph of f, then either f double prime, which would be the second derivative of c, is equal to 0, or f double prime, the derivative of c, is undefined. Okay, so to determine if there's a point of inflection, we're going to find the second derivative of the function, find the concavity in the intervals if the sign of the second derivative in the interval changes from positive to negative. That's our keyword right there, changes. So if we're looking for the sign changes of the second derivative. If it changes from positive to negative, or from negative to positive, and around a point, then that is our point of inflection. Okay? So if it changes signs from positive to negative, negative to positive, then that's our point of inflection. So to find the point, we put the x value back in the original function. So here we go. So on our first one here, we're just going to take the derivative, the first derivative. So that's going to be 3 times 2, that's 6x squared. And of course, that plus 1 goes away, right? Because the derivative of a constant is 0. Okay, then we're going to take our second derivative, and that's going to give us 12x. Okay, so now what we're going to do is set this equal to 0 like we've been doing. Set this equal to 0, so that's going to end up divide by 12 here. So x equals 0. Okay, so now what we're going to do is we're going to go from negative infinity to 0. And then we're going to go from 0 to infinity with our little table here. And we're going to determine if there's a point of inflection at 0. Okay, so we're going to pick a value between negative infinity and 0. So we're going to do negative 1 here, and I'm going to do 1 over here. Okay, so those are the values I'm going to do. So I'm plugging those into this equation. So negative 12 times negative 1 would be negative 12, right? And then 12 times 1 would be just 12. So yes, this is going to be a point of inflection because this one went down. That's a concave down, right? And this would be a concave up, right? So wherever that happens, that's when we're going to then put our point back in to our original equation. So we're going to do f of 0, and that's going to give us 2 times 0 cubed plus 1. So that's going to give us 1. So our point of inflection is going to be 0, 1. And again, that's because it went from down to up. Do another one over here. Okay, so again, we're going to take the first derivative of this, and that's going to give us negative 3x squared. Take our second derivative of it. That's going to give us negative 6x. Set that equal to 0 again. So that's going to divide both sides by negative 6. So x is equal to 0 here. So once again, we're going to do from negative infinity to 0. And then from 0 to infinity. In our table, we're going to do our negative 1 and our 1 here again, just like we did a minute ago. This time it's going to be negative times a negative is going to be a positive, right? So that's going to be a positive 6. And then when we multiply a negative times a positive, it's going to give us a negative. So again, once again, this would have been up. This would have been down, so that is a point of inflection because they are changing from concave up to down. So we're going to then plug in that value again. So we're going to do f of 0, and that's going to be equal to negative 0 cubed, which again would be 0. So our point of inflection this time is going to be 0, 0. So go ahead and do these two on your own and come back to me when you're done. Alright, so first derivative of x to the 4th is going to be 4x cubed. Second derivative is going to be 12x squared. Going to set that equal to 0 again. Divide both sides by our 12. So x squared equals 0, so x is going to be 0, because again we would have taken the square root, right? Okay. So here we go again, negative infinity to 0, and then 0 to infinity. So I'm going to do my negative 1 and my 1 here again. And so negative 1 squared is going to be a positive 1, right? So that's just going to be 12 here. And this is also going to be 12. So this is up and up, concave up and concave up. So that means it's concave up from negative infinity to infinity, doesn't it? Okay, so that means there is no point of inflection for this one. This one has no point of inflection because it does not change from down to up or up to down. All right, let's do this next one, okay? You can pause the video here, again, do it yourself, or come back, and maybe you already did. So, all right, here we go. So this is going to be 2x minus 3. And then our second derivative is going to be just 2. Oh, wow. So this is just, again, going to be from negative infinity to infinity. It's going to be up, right? Because that's positive, right? Okay. So that means, again, there is no point of inflection here. Okay. All right. The next couple examples are a little more complicated, so let's go ahead and do them. So again, we're going to do our derivative. This is going to be 3x squared minus 18x plus 24. And then our second derivative is going to be 6x minus 18. We're going to set that equal to 0. I'm going to move the 18 to the other side. So that's going to be 6x equals 18. Divide this by 6. So x is going to be equal to 3 here. So when we do this one, we are, again, negative infinity to 3, and then from 3 to infinity, okay? So here we go again. So I'm just going to do, let's see, what did I do? I did 0 and 4. Okay, so when I put 0 in there, 6 times 0 is 0 minus 18, so that would be an... Wait, where am I at? I'm looking at the wrong one. Yeah, that would be negative 18. Can't read my own handwriting. Okay, then this next one, if I did 6 times 4, that's 24 minus 18, that would be 6. So we went from down to up. So yes, there's going to be a point of concavity. So let's go ahead and plug that in, that 3 in. So we're going to do f of 3. That's going to be equal to, excuse me, 3 cubed minus 9 times 3 squared plus 24 times 3 minus 18. So f of 3, when you do all that, is going to be 0. So that means our points of inflection I don't know why it's down there again, yeah, but okay, that's a whole nother deal. Point of inflection is going to be 3, 0. Let's do this other one over here. So if we take the first derivative, that's going to be 4x cubed minus 36x squared plus 96x minus 64. Take the second derivative. That's going to be 12x squared minus 72x plus 96. Remember, we're going to set this guy equal to 0, so we're going to go ahead and factor it. I think a 12 comes out of everything, so that's going to give us x squared minus 6x plus 8. What are the factors of x squared minus 6x? So I'm pretty sure that's going to be 4 and 2, so that's going to be x and minus 4 and minus 2. Still have our 12 there. We're going to set all this equal to 0, so that means we're going to set each of those factors equal to 0. So that's going to be x is equal to 4 and x is equal to 2. So this time we're going to have a bigger table, aren't we? So we're going to go from negative infinity to 2. And then we're going to go from 2 to 4. And then we're going to go from 4 to infinity. So got a little more work to do this time. So from negative infinity to 2, I did 0 here. And then 2 to 4, that's going to be a 3 right there. And then I'm just going to do a 5 over here. So once again, you're going to put those numbers back into this function right here. Okay. So once you do that, I got 96 here. I got negative 12 there. And I got 36 here. So what happened? We went up, down, and up. So that looks to me like there's going to be 2 points of inflection. So here again, we're going to do f of 2, and we're going to do f of 4, right? So go ahead and put those into your original function up here, and then figure out what your value is. So when I did that, I got negative 16 for 2. And I got 0 when I put 4 in, okay? So that means we have 2 points of inflection. So our points of inflection this time, there are 2 of them, are going to be 2 comma negative 16 and 4 comma 0. So go ahead and do this next one and come back to me when you're done. Okay, so the first derivative is going to be 4x cubed minus 6x squared. Second derivative is going to be 12x squared minus 12x. Okay, so it looks to me like I could factor a 12x out of both, and that's going to give me x minus 1. Set both of these equal to 0. So that's going to give me x equals 0 and x equals 1. So those are going to be our 2 values we're about to put in our table. So we're going to do negative infinity to 0. And then we're going to go from our 0 to our 1. And then we're going to go from our 1 to our infinity. Okay, so on this first one, I'm going to do a negative 1 there between negative infinity and 0. I'm going to do a half right there, and then I'm going to do 2 here. Okay, so now we're going to plug those back in, remember, to this function. And when we do that, excuse me, we get 24 here, we get negative 3 there, and we get 24 here. So once again, we're going up, down, up. So we're going to have 2 points of inflection again. So we're going to do our f of 0. And when you put 0 in that original function, you're going to get 1. And then when you do f of 1, that's going to be 1 minus 2 plus 1. So that's going to be 0. So our points of inflection are going to be 0, 1, and 1, 0.